My name is Claudia Landry. I am a fourth grade math teacher at Raceland Upper Elementary, which is located in Lafourche Parish. I have been a teacher at Raceland Upper for 26 years. Throughout my time at this school, I have taught every grade and subject at this school. So that means I have taught 3rd, 4th, 5th grade. I've taught ELA, math, science, social studies. So I've taught every subject here. I am currently a 4th grade math teacher. And one issue that I feel very passionate about is that all students are able to soar and succeed. A lot of times we have students, especially students with disability, who may come with us with kind of like a learned helplessness. Like the teachers in the past may not have pushed them, they might have let them slide by. But I feel like expectations should be high for all students, and all students with the right guidance can become successful and soar to great heights. So the class that you're going to see the lesson on today is a 4th grade math class. In that class, there are 5 1508 students, 3 504 students, and 1 student who recently tested out of 1508. So the curriculum that will be used is Eureka Squared, and we are going to be doing a lesson from Module 4 of that curriculum. And the objective of that lesson is that I can generate equivalent fractions with smaller units for unit fraction. So the students are coming to me with a basic understanding of fractions that they learned in 3rd grade. So they learn what fractions are and how to find fractions of numbers in 3rd grade. In 4th grade, last week, we did a lot of decomposing fractions by sum of unit fractions, so they know what a unit fraction is. They already learned how to multiply and divide, which are skills that they will use to help them find equivalent fractions. Today, guys, is that I can generate equivalent fractions with smaller units for unit fractions. Now compare 3/6 to 4/6. Your answer. So let's read it together. 3/6 is less than 4/6. How does 0/6 compare to 1/6? Answer. So hold up your board. Now let's read it together. 0/6 is less than 1/6. What do you notice about the model? So there's a fraction model up there. What do you notice about it?
It looks like it was first 1/2.
Okay, so you see 1/2 on there? What
Is equivalent to 1/2.
Okay. What do you wonder about the model? Micah?
Why they broke the model up?
So why did they break up the model like they did? Anybody wonders anything different, or Bella?
Why is it still 1/2 even though there's...
So why does it say 1/2 at the top when we can see 10 parts? Put your thumbs up when you find a fraction that is equivalent to 1/2 using the model. So right now, I want you to turn and talk to your partner and tell them what the model shows is equivalent to 1/2. So ready? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. How many of those 10s are shaded in? 5. So that model is showing that 1/2 is equivalent to 5 tenths.
It's split into
Okay, you see that? Because if half is equivalent to which fraction? 5?
5/10.
5 tenths. And I think somebody said that when we said, what do we notice? So today we will generate equivalent fractions with smaller units. If I'm doing 4s, how many lines do I need, class?
3.
3 lines. Am I going to shade in, class?
1.
How many, class?
1.
1. So what kind of fraction is 1/4? Unit fraction, good. I'm going to 1/4 to something 12. So let's think about what I multiplied the 4 by to get 12. So what number times 4 is equal to 12? Turn and talk to your partner about what number times 4 is equal to 12. Ready? 1, 2, 3.
6 is 6. 6 because
So turn and talk to your partner and do number 5 together.
rest each 5 Now we have 12. So, and we have 6 shaders, so I think it's 6 12s. Okay, so what do we do with 6 12s in our equation? Well, our denominator needs to stay the same, so we put 12.
So what are y'all gonna do?
That's a decomposing of 12. But right now, this would be 1/3.
I think you would actually have to do 3 long. 3, 1.
So what's your multiplication? So what is it equivalent to? How many 12? So if you look at what you have 12, there's only 3 shaded in right there. Okay, so 1/3 is equivalent to 4/12. So good. So what would the equation be?
1/3 times 3 will get, 4 will get you 4, and then 3 times 4 equals 12.
So good, you multiply both of them by 4. So 1 times 4 is 4, and 3 times 4 is 12. With your group, you're going to do number 1 and 2, 6, 9. Then you're going to get out of group and do 3 and 4, 8 and 10 on your own. So remember, student teacher role, respect each other, quiet voices, and math talk only.
200 of 4, so our equivalent fraction is 2/4. To show that, we have to go to the equations. 2 times 1 is 2, and 2 times 2 is 4, so 2/4 is equivalent to 1/2.
We're gonna put a line through the middle, and then that'll give us 2 6.
Now to find out what is equivalent to 1/3, which would be 2 6
So what, how many sections?
For the last box right here,
Decompose each section into to get it from 3rd to 6. So each third would decompose into how many sections to get to 6? So look at 1/3. Look at one of the thirds. How many sections did you decompose it into? How many? 2. So you decomposed each of them into 2. So what did you multiply it by? So for your multiplication, what are you going to multiply both your numerator and your denominator by? So you're going to multiply them both by 2. That's correct. So you're working by yourself now. So now, how do you know that 1/4 is equivalent to 3/12? So what would your equation be? What would your multiplication be to prove that?
Wait, by 3?
So let's look at 1/3. So here's 1/4. So what did you decompose that 1/4 into? How many sections? 1, 2.
3.
So what are you multiplying each of them by? 3. So right here you're going to multiply 3 times 1, which is equal to what? 3. And what do you multiply your denominator by?
So my denominator would be, except for this one, would be 3.
So you're multiplying it by 3 also. So you're going to do 3 times 4. Here, you want to show that they're equivalent using multiplication. So remember, what number so you're doing times right here. So what did you decompose it into? How many sections? 1, 2, 3. So 3 times 1 was 3. And what times 4 is 12? So there you go. I want to do the multiplication. So what did you decompose each fifth into? 1, 2 sections. So that means you multiplying both of them times 2. So 2 times 1 was 2. And what did you multiply the 5 by? So 2. So 2 times 5 is 10. A lot of you are getting the equivalent fraction part of it. You're getting confused when it comes to the multiplication. What did you multiply? So let's look at this first. So on number 4, how many columns do they have? Let's count. Ready? 1,
2, 3, 4, 5.
So there are 5 columns. How many of those columns are shaded in? 5? 1. So we have 1/5. So this model is showing 1/5, and it's showing another equivalent fraction. So once they do that horizontal line, how many sections do they have? Let's count. 1,
2, 3, 4, 9, 10.
So that's 10. And how many of those tenths are shaded in? 5?
2.
2. So I think a lot of you figured out that 1/5 was equivalent to 2 tenths. The multiplication part confused some of y'all. So 1/5 is equal to 2 tenths, and we're showing the multiplication. So right here, when we multiply, because we use the model, there's 2 ways to figure that out. Let's look at 1/5. How many sections did they decompose it into? Let's count. 1, 2. So they decompose it into 2 sections, and we multiplying each section by 2. Or you can ask yourself, what number times 1 is equal to 2? So what number times 1 is 2? So to figure that out, 2 divided by 1, which is what, class? 2. So we multiply both the numerator and the denominator by 2. So 2 times 1 is 2, and 2 times 5 is 10. And we're going to be doing this for several days, guys. So if you're not getting it 100%, we will be practicing it again. Multiplication. Journey?
We did an equation, and we did, like just now, we did 1/5 is equal to 2 tenths. So 2 times 1 we equal to, and 2 times 5 we equal 10. So we had to have the same number to multiply to get the equivalent fraction.
So we had to multiply both the numerator and denominator by the same number, and since we decomposed each fifth into 2 sections, we multiply both of them by 2. And let me ask you a question. What happened to the pieces in my area model as I decomposed it into more pieces? As I decomposed it into more pieces, what happened to the size of the pieces, Micah?
It gets smaller.
So turn to page 83. Tear it out. Put your name at the top. So before you do your exit ticket, rate how you feel about today's lesson. 0, even with help, I don't understand yet. 1, I'm starting to get it, but I'm still confused. 2, I can do this with help or an example in front of me. 3, I can do this on my own. I can show I understand. And 4, I am very confident with this. I can teach it to someone else. So rate how you feel about today's lesson from 0 to 4 at the top. Then do your exit ticket. Once you are finished, do your reflection on the back. After reflecting on the lesson and looking at the exit ticket that the students did, I do feel like the objective was met. When I looked at the exit ticket, 100% of the students were able to find equivalent fractions on the exit ticket. The part that confused the students were only 78% of them could actually show it using the multiplication. So the actual objective of finding equivalent fraction was met, but they were confused with the multiplication. So next time I might use more like concrete, real life item to help the students understand it. I could maybe like bring in a Hershey boy and then show them like, Here's half of the Hershey board. Now let's break it apart into 8. So how many parts did I break each part into to show that we were multiplying it by 4 to get from 1/2 being equivalent to 4/8? So after this lesson, what will continue to happen is the 4 students that were not able to do the multiplication, they will be remediated in a high dosage tutoring group, and those skills will be going over to make sure that they understand it and they can get an understanding of it. And we're going to continue to teach lessons in Eureka Squared on equivalent fraction, eventually moving from not only multiplying to find equivalent fraction, but also dividing to be able to find equivalent fraction.